Hi, this is Lauren Winkler demonstrating the web mapping application I developed for Project 1 of UW-Madison's Capstone and GIS development course. Research suggests that there may be a link between high concentrations of nitrates and nitrites in drinking water and cancer occurrences. The Wisconsin Department of Natural Resources requested a spatial analysis to see if there's a statistically significant correlation between nitrate and nitrite concentrations in drinking water and cancer. They provided two statewide data sets. First were water well points with nitrate rates in parts per million. The second was cancer occurrences, expressed as a percentage of the population diagnosed with any type of cancer over the past 10 years. They provided data on cancer occurrences at the county and census tract levels, but I chose to use the more detailed census tract data for my analysis. To complete the analysis, I developed a leaflet web mapping application that uses inverse distance weighted spatial interpolation and ordinary least squares linear regression to examine the relationship, if any, between nitrate concentrations in drinking water wells and cancer rates in Wisconsin. In order to perform any type of spatial interpolation, the data being interpolated should be spatially autocorrelated. This means that nearby features should have more similar values than distant features. This assumption can be tested by running a Moran's eye test on each dataset in ArcGIS. Based on the results of those tests, both datasets exhibit statistically significant clustering, with a less than 1% chance that either pattern is a result of random chance. Because of this data can be used to interpolate nitrate concentrations and cancer rates to any location in Wisconsin. Since the Wisconsin Department of Natural Resources and concerned citizens may not have access to an ArcGIS license or even a desktop computer, I wanted to develop a web mapping application. The map was developed in Leaflet using Turf for the geoprocessing, simple statistics to run the linear regression, and the Easy Print Leaflet plugin to print the map to a PDF. When you first arrive at the map, you will see two layers. First are water well points, symbolized by their nitrate concentration in parts per million. The second are census tracts, symbolized by the percentage of people in the tract who were diagnosed with cancer in the past 10 years. Both layers are symbolized using the CK means classification method from the simple statistics package. You can click a well point to view its nitrate concentration, or you can click a census tract to view its cancer rate. To run the analysis, enter a distance decay coefficient and a hex bin size. The distance decay coefficient is an exponent in the formula for inverse distance weighted spatial interpolation, which determines how quickly the weight of a sampled value will decrease the further away it gets from the unsampled location. The larger the distance coefficient, the quicker the weight will decrease as its distance from the unsampled location increases. The distance decay coefficient can be 0 or higher, but it is typically between 1.5 and 2.5. This application accepts any value between 0 and 100. The hex bin size determines the level of detail to use for the analysis. Smaller hex bins are more detailed but take longer to process. Since census tracts vary greatly in size, I aggregated the data to hex bins so that the features could be shown without any bias toward larger census tracts. So to run the analysis, you will enter a distance decay coefficient and a hex bin size. If you enter an invalid or non-numeric number, you'll get an error message, and when you click OK, the values will reset. You click Submit with valid data. Within about 10 to 15 seconds, the application will generate 3 layers. The first is a layer showing the difference between the interpolated cancer rates and the predicted cancer rates based on ordinary least squares linear regression. The regression residuals are symbolized based on their standard deviation. Over predictions, places where the predicted rate is higher than the observed rate, are shown in blue, while under predictions, where the predicted rate is lower than the observed rate, are shown in red. You'll also notice that the regression equation and its R-squared are shown in the sidebar. You can click any hex bin to view its nitrate concentration, observed cancer rate, and predicted cancer rate. Switching to other layers, you can also view the interpolated nitrate concentrations. You can click any hex bin to view the specific concentration in parts per million, or you can view the interpolated cancer rates, where you can click any hex bin to view the cancer rate expressed as a percentage of the census tract population. Once the analysis is complete, you can click Reset to return to the original layers, or you can enter a different distance decay coefficient and hex bin size to generate a new analysis. This analysis will again show the regression equation and the R-squared that applies to this particular analysis. At any point, you can collapse the sidebar and click Print to print the map to a PDF. The printing takes about 10 to 15 seconds as well. In some cases, hopefully faster. If you wanted, you can print this to paper or PDF. I found that regardless of the parameters that I used for the distance decay coefficient and the Hex Bin size, I would get R-squared values between 0.08 and 0.1. Since R-squareds range from 0 to 1, with 1 indicating a perfect correlation and 0 indicating no correlation, this shows that there's little correlation between nitrate concentrations and cancer rates. However, I know this to not be true for all types of cancer. So one possible reason for the low correlation is that the provided cancer rates consider all types of cancer, while several studies have shown that there is correlation between nitrates in drinking water and specific types of cancers, specifically those associated with the digestive system. If the cancer rate data was broken down into rates for specific types of cancers, it is highly likely that there would be a significant correlation between nitrate rates and one or more types of those cancers.